Hi everyone. In this video I am going to explain about 4-bit and 8-bit comparators. In the previous video we have studied about 2-bit comparator where the two numbers, when we are comparing two numbers A and B, A is having 2 bits and B is having 2 bits. That's why it was 2-bit comparator. But now it is 4-bit comparator. So 4-bit comparator means it is also comparing two 4-bit numbers which is of size like A is having A3, A2, A1, A0 and B is having the size 4-bit B3, B2, B1, B0. Okay, so these 4 bits of A and these 4 bits of B are compared and then it will be called a 4-bit comparator. What could be the output after comparison? We know very well when you are comparing two bits or two um, things, we can say either it is greater than or less than or equal to. So it may be either A greater than B or A equal to B, or it may be A less than B. So any one of these three will be 1. Now this 4-bit comparator is readily available in an integrated circuit format with an IC number of 7485. 4-bit comparator readily available in a in an IC integrated circuit 7485. See here, the IC looks like this. So the 4 bits of A are applied to this IC along with 4 bits of B. Okay, so B0, B1, B2, B3, A3, A2, A1, A0, and here cascading inputs are also there along with 3 comparing inputs. Cascading inputs are also there, which is used for the next stages. That means 4-bit comparator. This 4-bit comparator 7485 can be used to build 8-bit comparator or 16-bit comparator. Like that, the number of bits inside the numbers can be increased by increasing this 4-bit comparator. We are using multiple times. Okay, the output of one 4-bit comparator is connected to or cascaded with the second 4-bit comparator when we are going for the multiple stages of this 4-bit comparators. Okay, so this is input for A greater than B, input for A equal to B, and this is the input for A less than B. Okay, when I say clearly about 8-bit comparator, then you can understand this particular 4-bit comparator cascading inputs. And we know 3 outputs. When we are comparing, we know very well A greater than B is one output and A equal to B, and it is A less than B. Okay, and the IC number is IC 7485. Okay, so once again I am repeating, listen. 4-bit comparator which is used to compare two 4 bits of data. So A is having 4 bit and B is having 4 bit. These are the 4 bits for A and these are the 4 bits of B which are applied directly to 7485 comparator, a 4-bit comparator. And the output we know very well, when we are comparing 2 bits of information, we will be having either greater than, less than, or equal to. Along with the current inputs are nothing but A3 to A0, B3 to B0. These are current inputs or comparing inputs. Along with these current inputs, we also have the past output. Past output is nothing but previous stage outputs, whether it is greater than, less than, or equal to. Okay, now let us see the truth table of this particular 4-bit comparator 7485. Truth table. Listen carefully. If you understand the truth table, then we can easily understand 8-bit comparator. See, comparing inputs. First one is comparing inputs. Second is cascading inputs. cascading inputs. Comparing inputs are nothing but current state inputs, A3 to A0, B3 to B0. And cascading inputs are I A greater than B, I A less than B, I A equal to B, and outputs A less than B, A greater than B equal to B, present state. Okay, now comparing inputs are A greater than B, comparing inputs are AB, and these are I of A greater than B, I of A equal to B, I of A less than B, and it is A greater than B, A equal to B, A less than B. These are the current outputs. Now see here, this comparing inputs AB, when these two are decided by A greater than B, these two are decided by A greater than B. Current state inputs, if it is greater, then irrespective of the status of cascaded inputs, the output is A greater than B. Okay, when the current state says it is A greater than B, then irrespective of the previous cascaded inputs, we can directly say that it is A greater than B. And when A equal to B, otherwise A less than B, we can write first. When it is A less than B, irrespective of the current cascaded inputs, then we can say directly it is A less than B. And now coming to the case where A is equal to B, then if it is A greater than B and remaining are zeros, then the output is A greater than B. If it is A equal to B, then the output is A equal to B. If it is A less than B, then the output is A less than B. Hope you understand what I am saying. When the current integrated circuit IC7485 says, based on the current inputs, if it is greater or less decided, then the overall output is the same, A greater than B or A less than B. But if the current state is A equal to B, then it has to go for the cascaded inputs decision, whether it is greater than, less than, or equal to. If there also it is equal, then we go for equality condition. Okay, you can better understand this particular table if you go for the 8-bit comparator. 8-bit comparator clearly works on this particular table. Okay, because it needs cascaded inputs, current inputs, and as well as outputs. Okay, just from that truth table, we can write the Boolean expression for the three outputs, A greater than B, A less than B, and A equal to B. So the Boolean expressions for the three outputs are A less than B is equal to A3 bar B3 plus okay, I will take it as I3. I3 is nothing but previous stage output, cascaded input. I3 A2 bar B2 plus I3 I2 A1 bar B1 plus I3 I2 I1 A0 bar B0. And similarly, A equal to B is equal to I3 I2 I1, and A greater than B is equal to A3 B3 bar plus I3 A2 B2 bar plus I3 I2 A1 B1 bar plus I3 I3 I2 I1 A0 B0. Here I3 is equal to I of A greater than B, and I2 is equal to I of A equal to B, and I1 is equal to I of A less than B. Okay, these are the inputs we have taken for getting the current state outputs. Now coming to 8-bit comparator, with the help of these 4-bit comparators, 8-bit comparator. So the count says that 8 means 4 plus 4. So two 4-bit comparators we need for the implementation of this 8-bit comparison digital circuit. So we need two 4-bit comparators. We need two 4-bit comparators to implement 8-bit comparator. To implement 8-bit comparator. Okay, see here we are taking two 4-bit comparators. Listen carefully. This is cascaded input A less than B, and it is A equal to B and I of A greater than B. Same here also, A less than B, I of A is equal to B, I of A greater than B. The outputs are connected like this. This is A less than B, A equal to B, and it is A greater than B. These are the outputs, and we are assuming that this last stage is connected to A equal to B is connected to 5 volts, and these two are connected to ground. Okay, and now this is the current state, A less than B, A equal to B, and A greater than B. Okay, now take the 4 bits of A and again 4 bits of B. Here also 4 bits of A, 4 bits of B. See, what do you mean by 8-bit? 8-bit means A7, A6 and so on, A0, A1, A0. And similarly, B is having 8-bit data. So, B7, B6 and so on, B1, B0. So, we need to split this total 8 bits of input data into two 4-bit data like A7 to A4, B7 to B4. This we have to apply for one comparator, and similarly B7 to B4 and B it is A. A3 to A0 and B3 to B0 we should apply in this way to these two comparators. Okay, now the question is where we need to apply the higher order bit and lower order bit. See, this A7 to A4 and B7 to B4 are the MSBs of the two inputs, A and B. Okay, MSBs of the two inputs, and A3 to A0, B3 to B0 is nothing but LSB of the two inputs A and B. Okay, now where we have to apply, whether the first comparator or second comparator, which one we need to apply with MSB and which one we need to apply with LSB. See, this is 7485. This is first comparator. 7485 second comparator. Now look here, coming to the table, when the current comparing inputs is saying A greater than B, or A less than B. Irrespective of the cascaded inputs, we can directly say that whether it is a greater than B case or A less than B case. When we go for the cascaded inputs, when A is equal to B, when the current state says it is A equal to B, then we go for the cascaded inputs. Depending on the condition of the cascaded inputs, the output will be coming. Okay. Now with the same concept, see here, consider for example, A is consisting of a number 1010 and 1000. Okay, this is 10 and this is 9 individually if you see. And similarly, B is having a number like 1010 and 0111. This is 10 and this is 7. Now this is MSB bit. This is MSB bit. What is MSB bit in this case? This is MSB. MSB stand here, and here it is MSB. MSB stand here. As the first set of MSBs are equal, then we go for the condition of LSB comparison. Okay, see here. Now coming to LSB. So as MSB of A is equal to MSB of B, we should go for LSB comparison. LSB comparison. So LSB of A, see LSB of A is 9 and LSB of B is 7. So which is greater? LSB of A is greater than LSB of B. LSB of B. So overall we can say A is greater than B. This is first example. And similarly, second example I will tell you. A is equal to same condition 1010 and 1000. Now taking B as 1100 and some 000. Coming to the MSB, MSB it is 10 and MSB it is 12. MSB it is 12. Then compare MSB of A, which is less than MSB of B. So by comparing the MSBs only, we can directly say that this directly gives the overall result as A is less than B. Then we no need to go for checking LSB again. If the result is declared at MSB, whether it is greater than or less than, then we no need to go for the comparison of LSBs. If MSBs are equal, then we should go for the comparison of LSBs to get the final result, whether it is greater than, less than, or equal to. Okay, in both the cases, suppose A is equal to 100, 100 and B is equal to same number 1010 and 1000. This is 10, this is 8 and here also it is 10, it is 8. When here MSB of A is equal to MSB of B and LSB of A is also equal to LSB of B. As MSBs are equal, we go for the comparison of LSBs and LSBs are also equal, then we can directly declare that it is A equal to B. Okay. Now, what we have to understand here is that when we compare first MSBs, the answer is completely declared from MSB only. If MSBs are equal, then we should go for the comparison of LSBs. Okay. So coming to here, we have to consider B4, B5, B6, B7, A4, A5, A6, A7. What do you mean by this? This operates on MSB, most significant bit. MSB 4 bits. And again B0, B1, B2, B1. Sorry, B1, B2, B3, A0, A1, A2, A3. Okay. Now if we declare that A is greater than B in the MSB, then we can directly say that it is A greater than B without checking the cascaded inputs. That is what the truth table says. If A is greater than B in the comparing stage, we don't need to worry about the cascading inputs. Directly we can declare that A is greater than B. And similarly, when A is less than B, then when A is less than B, then irrespective of the current states, then output is directly we can declare it as A less than B. But when A is equal to B, see here, when A is equal to B, suppose when you are comparing the MSBC A equal to B, then we have to go for the comparison of lower order bits. So whatever this says, that will be the output. Okay, so this is what the 8-bit comparator and its examples. Thank you.